Okay, let's just get started for the sake of time. I think we're supposed to end at 4:45 today because there's a happy hour people are encouraged to attend back where you guys picked up your registration packets. So we're encouraged to give you guys a few minutes to walk over there. I'm going to move into some stuff on just using R to import and also export data. So there were a few questions related to GitHub that came up in the break. One of them was about just like large files. What do you do if you have large files? By default, GitHub can only basically archive up to 100 megabyte files. You'll actually get a warning above 50 megabytes. There's actually a thing you can do, though, if you have large files. There's a file called git ignore, which is sometimes made in your project when you initiate it. Other times you actually have to make it yourself. The idea is that there's this file that's a hidden file to your computer because it starts with a dot, and you would just put whatever files you want to just ignore when you push and pull from GitHub. That just means if you have a several gigabyte file, you don't necessarily need to version control it if you never actually modify it. So the idea with that is you only really want to be version controlling things that change. And so you would just put a specific file in this git ignore, you would commit it, and then you would add the file to your GitHub repository. And then anytime you pushed or pulled on your computer, you would not be pushing and pulling that large file. And you'll sometimes, if you do files between, I think, 500 or 50 megabytes and 100 megabytes, you'll just get a warning saying, careful, you can't go over 100. We don't recommend going over 50. And so that's just a little warning that you might run into in practice. That actually affects me all the time, and it's kind of annoying. But that's just one sort of caveat with using Git. Otherwise, we kind of went fast through that. Some people might not have followed it all the way. The good news is that we're not really going to be using GitHub for the rest of class. There's really more of an exposure that, a lot of people in data science will use GitHub in their day-to-day jobs. So not everybody, obviously, and so we just want people to be familiar with it. If someone's like, "Oh, like you use GitHub," you can be like, "Yeah, I know what it is now. Like it's it's fun. It's terrible. You'll have an opinion on it now." So that's kind of what we were going for with that. And so again, it just is very prevalent in anything collaborative with data analysis or coding, or programming or things like that, where if you're working with somebody, the odds are you'll be using some sort of version control just to avoid the headaches of trying to compare things that have changed over time. That's really what it's good with. And so I'm going to be moving into more of actual R coding. Let's see. There we go. And so this is all going to be using R. And the idea is today we're going to be just going over how to read in data into R, very basic types of file formats. And so just as a caveat, Jeff was using Google Slides. I'm actually using R Markdown, the slides output format. So this integrates both the code and also the results in a lot of the material. And so anything that's sort of gray is actually like R code that then prints out the results. And so again, this is just another way of outputting ways of writing R Markdown documents that just looks like slides instead of looks like an HTML document or looks like a PDF. And so just some common new user mistakes that we've seen. And then Jeff had covered a few of these. It involves sort of these working directory problems where you're trying to read in a file or locate a file or open a file that R can't seem to find. Using something like projects helps with that. You can also pass complete paths to files to help alleviate that. Another issue sometimes just lacks of comments in codes. Usually you'll just start writing just R code, and then you'll just have this long document of just straight code, and you'll be like, what did I do at line 2? I don't even remember why I typed that. What's going on? Commenting helps with that. Just typos. R is case sensitive, so lowercase x and capital X are different. And so things like tab completion, which you might have noticed as you've been using RStudio. So if you have some files open, so if you have some file, and so if you have something in your R session, you start typing the actual variable name and press tab, it'll give you options of things that start with that string. And so if I press tab again, it'll complete it for you, and so that helps cut down on typos. That also happens if you have a script open and you're sort of working interactively. The script knows what's in your R session, so it can actually use tab completion as well. And so that sort of prevents you from needing to type super short, nondescript variable names. And so there's also issues with data type. So whether you see some data, a column of a data set, and you don't know whether it's a character or a number. Different functions do different things to those. That also causes issues. And again, we're gonna cover this stuff in the class, and so this isn't like the only thing we're gonna talk about this. There's also things where you just forget to close parentheses or quotes or brackets, or you take something to a new line and something gets messed up. And then the last one is different versions of software, but again, Jeff had already touched on that with the session info, where you can see exactly what versions you're using when you try to figure out exactly what's going wrong and when you're trying to troubleshoot how certain functions work. Jeff covered this, so I'm going to go through this quickly. R looks for files on your computer relative to the working directory. You don't really need to necessarily set this in a script, especially if you're using RStudio. It's pretty smart about if you open a script, it'll typically set the working directory to the location of that script. The key is if you do like setting a working directory, it's good to sometimes use relative paths and you put it at the very beginning of your script, especially if you'll be sharing that document. We'll just skip this. And so if you are going to be sharing your code sometimes, it is good to use relative paths. Other times, you might prefer full path just so you know exactly where it is. And so the key difference is a relative path just starts wherever that file is located, whereas an absolute path can just be the extended path to wherever that file is on your computer. So I know Jeff had said it's not great to use drop-down support. However, some people might find it a little bit easier when initially getting started. Unlike other software like Stata or even a little bit of SAS, there's really not that much drop-down support. And by drop-down support, I mean like options, like actual commands up here in the actual toolbar. So one thing though is you can actually, what's nice with some of these are that if I say set working directory to project directory, you actually get the code that runs that command. So it'll set the working directory, give you code, and then you can copy that code into a script, and so that could like start becoming your R script. And so that's sometimes nice in terms of just, it doesn't just do it and you don't know what happened. It'll do it, give you the command for doing it, and so then the next time you can just copy the code out. And so for example, if I just were to manually go to lectures, data IO lecture, it would set that working directory and give me the code to do it. So now you should have R installed. You probably have RStudio open. We can now make a blank script. Here we can actually just use a regular script. We don't need to use R Markdown necessarily. You can if you want. It's just a little bit harder to use. And so let's start a script calling day one. And so you can also just press the plus button with R, and then our script is the default. And so then you would just start typing here and save it. And so then typically what you want to do is add something like a comment header. And so in order to do that though, so then what you can also do sometimes too, if you haven't really used RStudio very much or use R very much, sometimes R doesn't know to open R files with RStudio. So you probably might have to make RStudio the default application for handling the .R extension. That's especially true if you installed R first and you installed RStudio, where maybe it just associates R with R files and not RStudio. So for Mac, you can right-click, get info, open with RStudio, and then change all. Windows involves finding an R script. Finding an R script, saying file, properties, change what it opens with. You would just change it to RStudio, and then say always use the selected to open this kind of file. And so that should hopefully in the future allow you to open everything with RStudio. And so now, for example, if you closed RStudio and you made this change such that all .R files are associated with RStudio, if you double-click the day1.R script you made, it should open the script. It should set the working directory to wherever you open the script from, and then you should be ready to go. You can check to see that you're in the right location you can just check when it says files. This is a pane that tells you sort of all the local files in your computer in that particular location. You can then just confirm that that script you created is in there. Another thing with R, just sort of an aside, is that the question mark or the help function tell you more information about a specific function. And so if you want to learn how something works, you just type question mark and then the file name. So for example, if I want to understand more how dir works, in that same pane, it'll also open up any sort of help. And so, it gives you the name of the function in the top, a little sort of a more detailed name, a description. It gives you pretty detailed usage guides where it tells you all the arguments you can pass to a given function, and if providing some of their default values. And so what you can do, it also gives you more information about each of the arguments. And so also then what gets returned by the function, which is useful. And then some examples that should, if you copy and paste them out of the example guide, they should run for almost all of them. And so you can just see how they work in practice by just copying and pasting out of the examples. And so that's nice if you're not quite sure how something works, or you have sort of questions about some of the inputs. If you're having a hard time Googling that particular function, sometimes just looking at the help is the easiest thing to do. And so commenting is super important. And so you should be able to basically, just like Jeff's comment that your best friend is yourself 6 months ago or something, or your closest collaborator is yourself 6 months ago. With commenting, that's one way of actually remembering what you did in a particular analysis. This happens to me pretty often, just like it's happened to him. Like a year ago, I got an email saying I'm working with this guy. I remember that paper you published in 2011. Like, how did you make that figure? And I was like, so the code was made in about 2011. The email came in 2016. So that was the figure he was talking about. And so I had to do some digging, but you eventually find it. I was able to find the script because I looked at the comments, and I was like, that's how I made that exact figure. So it's really important to keep a good file system and to include a lot of comments in your code. That's probably the 5th time something like that's happened to me. It will eventually happen to you one day, and it's way faster to find the object than it is to recreate it. So it's, again, good for naming convention and for commenting. And so commenting is good for something like this. So the pound sign in R is the comment symbol. Something like this is typically good to include at the top of all your scripts. Just a little, you can make a fancy little box with pound signs. You can say what the title of the script is, who the author is, maybe date last modified, maybe a little purpose statement. It also looks pretty, so it makes it look like more professional. And so with all these comments, all you really need is one pound sign. Having 12 in a row doesn't really do anything for you. So the key is that once you have one, everything to the right is just not evaluated. And so if I put one here, I can put more of them. It doesn't really matter. It's not like other languages where you sort of like bracket in or sort of like encapsulate comments with 2 different patterns of symbols. You can use as many as you want. Other times, if you have long comments, which I often do, you might want to just use multiple lines. So you would just say pound, part of the comment, new line, pound, more comment. And so what's nice about RStudio is that when you do this, it actually turns a different color. And so day 1. And so they turn green, and so you know it's a comment. That's especially true if you just have a comment in line. So you'll see, let me make it a little bit bigger. You can see that all the comments are green. You can see that this X is black, the 2 is blue, and then the comment, the pound, and everything to the right is green. And so there you can just see an example where nothing with comment gets evaluated, even though you can type it on your console. And so as far as R is concerned, it doesn't exist, but it's good for you to leave notes for yourself for exactly what you were doing and maybe even why you did something. And so just more generally data input. So reading in data into R, your other favorite data analysis tool, is the first step of any real project or analysis. And what's sort of nice about R is that it's really flexible. You can read in almost any file format, especially via the add-on packages that you can install from CRAN or from Bioconductor. They can read in a lot of sort of these like binary proprietary formats that other tools might not be able to, as long as somebody's written a package that knows how to parse it. However, in today's class, we're going to focus on 3 really simple examples. Tab delimited files, which are typically delineated with a .txt extension. Comma separated values are .csv, or the number 1 data analytics software in the world, Microsoft Excel, with the .xlsx. And tomorrow, Jeff's going to cover more complicated or more advanced file formats like JSON, data tables, Google Sheets, and things of that nature. And so just for today's lab, we like trying to use as much real data as possible in this class and sort of other classes where you teach people R. I used to have a boring example before where there were just monuments in Baltimore City that were listed. It was pretty lame. Now I found I've upgraded to UFO sightings. And so basically this is from a site called Kaggle.com, where they basically have data science competitions or machine learning competitions. So they have a bunch of just random data they put up there and these companies pay $10,000 for you to like optimize their algorithm for a certain project, and whoever gets the highest prediction score wins the money. It's kind of cool. And so the idea, this is a UFO sighting, so it's reports of unidentified flying objects in the last century. This is just sort of a little bit of information about it, and this is where the data comes from if you want to check it out to get a little bit more information. So I made it easy for you. I downloaded it, saved it as a CSV file, and put it on the SISBID site. So you should be able to download this file directly. When you click it, it should just open. It should download in your browser. You might want to, just to get started, open up in your favorite zip application, and then just drag this to the same location as your day1.r folder, wherever that script is. And so this like puts it in the same path, and so you don't really need to mess around with absolute file paths or really finding the working directory or changing anything related to the file path. And so I'll give you guys a sec to do that. And so with data input, the easiest way, which again is not the recommended way, is to just do something like, they move the location. So now it's under File, Import Dataset. And so this is, again, an example of drop-down support that if you don't really know what R does or how to do things in R, this is a good way to just get started. So you can just select from CSV. And so then it pops up this box. It's a little bit hard to see on this computer just because of the resolution. But the key is you would then go find the file that you downloaded. See where I put that. And so, just I guess as an aside, you don't actually have to unzip it. It just makes it easier for you to sort of conceptually understand what it's doing. R is perfectly capable of reading in zip files or writing out zip files, which is nice because they save a lot of space. And so what happens is you give it the path, then it tries to guess the file format, and it tries to guess all the column names. Again, just because the resolution is so large, you can't really see that it'll usually show the first few lines for you in the first few columns. One thing you can also do is change the R variable name that this will get imported as. So that's what that name thing means. The name field means. It's also asking if the first rows should be treated as the column name. So in this case, they are. You can tell that when if you change this, it shifts what the preview looks like, and so then you can then shift it accordingly. It's common to limited. If there's spaces, trailing or leading spaces, do you want them trimmed? And then do you want to pop it open in this sort of pseudo version of Excel in this particular RStudio session? But so what you'll see is as you change these settings, you'll see the code preview that can reproduce the importation of the data. And so you won't have to ever actually do this again. If you run it the first time, you just hit import. You might get some warnings that we'll talk about a little bit later in data cleaning. But what will happen is there's another type of file, another type of thing that RStudio does that's called these table views. And so this looks like an Excel sheet. Just sort of a snapshot of your data set. It tells you how many entries there are. You can see the little, it might be hard to see now, but the little logo is this sort of calendar looking thing, really like a spreadsheet view. You can sort of move around and see some of the underlying data. And so it's just a way of previewing exactly what you imported. You can get back to that with anytime in the future, but the capital V view, and this is the name of the data frame. And just another things with R, if people aren't super familiar, that once you read something in or once you make an R, oh, yeah.
Could you redo like the data input thing again?
Yeah, so then just from the drop down, if you have File, Import Dataset. So if you have an old version of RStudio, I would say more than 9 months old, this would be found somewhere else, I believe in Tools or Session, but I think in the last 9 months, if you've updated this, it should be here. You go the type of file. You then find the file on your computer with just browsing it through Windows Explorer or through OS Finder. It can be anywhere on your computer. And then again, you won't be. There's usually a preview associated with it that I can't quite show. But again, so once this and then you would select the various options that best fit your particular data set. Sometimes you might need more flexibility than what's offered here, which is also why we don't necessarily recommend the drop-down menus. But again, if you're getting started, it's very useful. And so you'll get this message where it's trying to guess what columns should be found in them. It gives you a little bit, there's some warnings that come up, again, you can ignore. And so the key, though, is when you use something like this, is that if you look at the history, you can see the exact command used to actually make this. And so if you're in the history, you have a few options. You can type, there's a to source button. So if I highlight a line of code in the history and press to source, it'll actually copy it to my script. And so, you can play around with stuff in the R console that you're not quite sure if it works. You're trying to get the code syntax correct. You'll try a few things. It'll say, warning, you forgot an error, you forgot a quote, error, like I can't find that file. Then, the third time's a charm, you'll get it right. And you'll say, okay, let me copy that into my script so I don't have to do that again. I don't use the dropdown again. And so what's really happening is that once you've run it one time, you can just run that line of code. You don't have to go through the dropdown. The exact command that you maybe created with the dropdown is there for you in your script. And so, yep.
So it looked like a CSV file, and then when I drug it to my Windows laptop, it changed it to Excel. At least the icon. I imported it as CSV and it was working fine.
Yeah, so it's probably like how we set the default program. Excel is probably the default program for most CSVs.
So if I'm going to use this laptop for all of my work and art, I should change that default?
No, CSV, that's totally separate, right? Like on mine too, I can open it. Like what I'll typically do is if someone sends me a data set, I'll just glance at it in Excel or a text viewer. Yeah, so it's totally normal. You don't want RStudio to be associated with Excel because if you just opened it in RStudio and not imported it as an Excel file or as a CSV file, it'll say, I don't know how to handle this. But again, it's useful just for taking, again, another type of snapshot, especially if there's some options where sometimes people will put comments in the first 7 lines and you might not know that when you try to read it in. So then I'll typically open it in Excel, view it to make sure. The only thing that you don't, so in genomics, there's this crazy problem that I can't believe it's still a problem with these things, these gene symbols, which are usually alphanumeric symbols. And some of them are SEP9, OCT6. And so anytime you ever open it, Excel touches it, it completely changes the underlying data. So in genomics, just careful with Excel. Again, it's crazy that it's still a problem 20 years after Excel's been around, but that's the only time where Excel will permanently change your underlying data for you that you don't want it to do. But so in general, you can read in CSV files, and so you don't have to unzip them. That's also another nice feature of R. It just knows, as long as it's well formatted. So sometimes, which is problematic, is you'll get a zip file that looks like it's a csv.gz, but it's really done in some other way that R might not be able to parse. You might have to manually extract that out. But it just saves space. And so the other thing, and so actually the default ways of reading in data are these sort of base R functions called read.table and read.csv. And by base R, I mean ones that come with R that you don't have to install any add-on packages for. But so there's this package by Hadley Wickham called reader that does read_delim and read_csv. They both do pretty much the same thing. The arguments are slightly different. The only reason we really focused on the underscore version is that the RStudio now defaults to the underscore version using reader. And so you can actually see that when you went through the dropdown in the code. So if I don't select any file, you can see in the code preview, this is how you would actually do it. You'd say library reader, so you'd make sure it's installed and can be initiated. You then do the command to read in the data set, and then they just view the data set. So you can see unchecking something like Open Data Viewer just removes it popping up, which could be good if the file's huge. And so then what's going on behind the scenes? So you're easily able to read it in as an R object. And just to confirm, one other pane that's really useful is this thing called your environment. And so this is all the data sets in R objects available to you that you can just type and run and evaluate. And so as soon as you imported it, whatever you called it should pop up in the bottom left as a data set. And again, you can click certain things and see a little bit more information about them. But that's how you know you imported something successfully if you just were to clear everything. So this is what happens typically when you start a session, your environment's empty. I run this command, and now, boom, I have my data set. And so then if I type head if I just look at the head of the UFO, now you're able to just type UFO, and R knows that it's the thing you just read in. And so then what's going on behind the scenes? If you actually look at the help file for read to lim, this is just taken from that. And so I can just pull that open. And so with any of these, just to expand a little bit, typically there is for any given function, there's things that are required arguments and things that are sort of take default values. And so what you can see is that if I want to run read to lim, you see there's something just called a variable called file, a variable called delim, then a whole bunch of other ones that say like quote, and they put something in there. Escape backslash is false, escape double true, column name's true. The idea is like in order to get this function to run, all you have to do is provide two arguments, which are the file because it doesn't have a default value, and the delim, which is what separates the columns, which also does not have a default value. And so everything else, it just tries to make the best guess based on just common data structures. Sometimes you might say call names is false if the first row is not header names, but instead data. Maybe the quotation marks are single quotes instead of double quotes. And so maybe skip, you'll want to provide something. And so you don't actually need to provide any of those. So like you don't want your read to lim call to have like the file name, the delimiter, then all of these things that are already set to their default values. It's not necessary. R just knows what they are based on what's provided in the help file. And again, there's other details in the actual arguments that gives you more information about all of these different options. And so the minimum to run this is you have to give it a file name and then delimited. So for example, you say read delim, file.txt, and then delim is tab delimited. Another nice thing is that if there's just a table somewhere on a website that's just some URL and then there's a table that they directly link to, you can actually just pass that as the actual file name in the read to lim call or in the read.csv call. You would just copy this exact thing. This doesn't work, so it's not a real table. But you can actually, you don't even have to download it. You can just read it in directly from the internet. And so just like there's a read to lim, there's a read CSV. This, as you can imagine, just basically sets the delimiter to be a comma. That's the only difference in the two functions. And you can also pass other options. It also changes a few of the other arguments. But now for this, you would just need to say just the path to this CSV file. And so what it's doing, and so if you don't put the question mark and you just type the actual function name, it spits out code that actually is the underlying code of the function. And so all it's basically doing is it's taking in the arguments, like sort of putting them in a certain order, and then just calling read delimited. So it's actually just like it's just sort of a wrapper function for read delimited that just takes a CSV and then just takes all the settings and then just passes it forward. And so if you're going to run that from the command line, you can just type your command in. Again, I'm using a relative path to the data folder, and then a UFO subfolder, and then the UFO data complete. And so when you run these reader versions, like the read underscore delim or the read underscore CSV, if you're used to reading read.csv or read.table or read.delim, you'll get a data frame. Here you'll get a special data frame called a tibble. And that's just a little object that controls what gets printed out when you actually run it. And so this is what our studio sort of moved towards, are these little tibbles. They have pros and cons. It's nice because you'll never crash your R by accidentally typing a huge 700 million line file that will immediately destroy any regular R session. And so you can see if I were to type in the data frame, you'll see that it only puts in as much as it takes to fill my screen. It'll never just keep going. Instead, if I were to say as.dataframe UFO, it's just going to either crash. I hope it doesn't actually crash my R, but it just basically starts spitting out as many lines as it can. Again, this is if you have a really, really big data frame, this will typically crash your R. But then, in this case, it printed out only 80 lines and then said we omitted another 90,000 more. So it's a little bit harder to get a glance of what's going on. So that's why the tibble is nice for that.
Is it easy just to convert from a data frame?
Yeah, all you do is as.dataframe UFO, as.dataframe the tibble name. I typically do this because I don't like tables very much because I'm not used to them, and anything that's new scares me. So I mostly use the data. This is like the first line I'll run, just because typically I like looking at all the columns. You only really get a snapshot of the first. So if I say UFO 2, typically you'll just be able to look at like the first row just to get a sense. And you can't really do that in a tibble. It still just stops it. So all it'll print is it'll basically print like the first 6 columns, and then dot, dot, dot. There's 5 more variables: duration, comments, date posted, latitude, longitude. You don't get to see what's actually in them, just sort of a rough sense of their structure. But I like being able to typically see all the data in maybe just one column, just so you sort of know what you're getting. Again, there's pros and cons of both. It's sort of personal preference, honestly. Once you start doing filtering, it doesn't matter if it's a tibble or a data frame. You can apply the same functionality typically to subset rows or columns. So again, it's more of a personal preference thing. And so the other thing is, if you just read it as a tibble, there's a function called class that tells you sort of what our class is that our object represents. So the only difference is it just has these special things. It just tells you that it's a tibble essentially, but it also has properties of a data frame. So compared to something like, typically you might expect just a data frame to come back, but again, there's certain attributes that tibbles have that data frames don't have, and that's all that is basically saying. Yep.
How did you read it in as a tibble?
So if you use,
Baked into the function?
yeah, so by default, any of the reader types of importing data. So, So if you use the drop down, for example, or if you just use the ones that have underscores, by default they'll be read in as a tibble. If you use the base R versions,
You're saying, so you read it in like that, and then you convert it.
yeah, exactly. So the easiest way is to, and the good thing about the underscores is that it's much faster to actually read things in. I think it's about twice as fast for large files just by how they parse the text. But so typically my script will look something like, I'll do something like this, where I'll read in the file as a tibble, then I'll just quickly convert it to a data frame. Again, just so I can look at more of the data in one shot. But so the other way to do it, if you want a data frame directly, would be to just use the read.csv function, which has very similar arguments. And so that would just come in as a data frame. You can see it's actually taking a lot longer than the other one did. And yep.
Did you say it takes twice as long just depending on their underscores or spaces?
So,
Like how you name your files?
no, sorry. So if you use, so there's 2 flavors of data import. There's like the base R functions, which are these things like read.csv and read.delim. And there's also ones that have read underscore CSV, read underscore delim. The read underscore versions in the reader package are much faster. And they're also nice because if you have like say you have a gigabyte text file that, if you were to run that in regular R with read.csv, you'll be sitting there for 15 minutes while it gets read in. All the ones in Reader have a progress bar by default, and so at least you'll know that the computer hasn't just frozen on you. And it's also faster. And so typically, I just prefer, if I'm going to be reading in big files, to use the Reader versions with the underscores, then just convert it to a data frame as the first step in a script. And so for the sake of this class, we'll almost always use the read underscore because, again, it's in the dropdown. It sort of plays the nicest with our studio, and it has good functionality like being able to read things in faster and a progress bar. But again, you can use whatever you want. The problem is that if you Google search for like how to do something in R, for code examples in R, they're almost all using the base R imports. It's like the read.csv, read.delim, only because that's been around almost since as long as R has. Whereas the read underscore versions are pretty much new, and they've only been defaulted in RStudio within the last year. And so that's why you might have a harder time looking at code online to use for your project if you use the reader. But again, you can almost always just completely replace read.csv with read underscore CSV and get exactly the same thing imported. And so here again, you can get the same example. The other thing that it'll do a little bit differently is how it handles the column names. Here you can see that if there's sort of weird characters that R doesn't normally like as column names, it just replaces them with periods. That's a little bit different than what's happening here, where it'll actually preserve the spaces and it'll preserve the parentheses and the slash. That's usually not what you want to happen. So you'll typically, again, in practice, you'll read it in with the underscore, you'll change it to a data frame, and you'll rename the column names to something that's easier to type. And again, we're going to cover that in the next 20 minutes. And then the last thing that's really annoying about the base versions are that there's this class, which I'll cover in a second, called factors. The base versions all default any character string to a factor, which are just harder to perform cleaning on. And so there's an option called as.is equals true. You almost always want to say as.is equals true if you use base R imports. That just says anytime there's something that looks like a character string, treat it as a character string. And then again, that's something that reader automatically treats all strings as character strings. So it already knows. Yep.
So it seems like you're showing us both the base R version, read.csv,
Yeah.
and also the newer version,
Mm-hmm.
as part of this reader package, just so that we understand that
Yeah.
existence. But that, I mean, at least for me, how it feels is like this is new regardless, so it sounds like the better way to go is to do read_csv.
With the caveat that you might not find as much initial material online for how to do certain things. Like if someone's like, how do I like read this in and make a plot? They'll be like, read.csv file, plot X versus Y. Just so you understand that like like once you've used either, you should be able to use either one or at least know what either one's doing, but you'll end up gravitating towards one in practice. Just because you don't want to have to jump back and forth. So we're going to go a little bit more into detail on some R variables. The most, I guess, comfortable class for many people will be the data frame class. This is pretty much an Excel spreadsheet type format that have observations down the rows and variables across the columns. However, R sort of structures these in a maybe not quite intuitive way. So what's really happening is each column has its own class, and then a data frame is sort of a collection of different R objects. And so these one-dimensional classes, or what I'll call vectors, there's different types that they can be, and the type of, or the class of vector determines sort of what functions you can apply to it. You can't really add two character strings. R doesn't really know how to do that. And so the ones that are most popular that encompass 95% of things you'll encounter are character strings. So that's any string or individual characters encapsulated in quotes. You can be either single quotes or double quotes. Numeric is any real number. Integer is any integer whole numbers. This one's a little bit harder to encounter in practice. Factor or categorical variables or qualitative variables. Logical is just a variable that's composed entirely of truths or falses. And then dates or POSIX represents calendar times and dates. And so, for example, if you have a character string that looks like dates, R can't do much with it, but if you say, hey, let's convert you to a date string, you can plot it on the x-axis and it knows to put things in sort of temporal order. And so again, we're going to touch on all of these. So just when you're in R, R can just perform different functions to entire vectors of numbers. And so if I make this temporary vector called x, so say x equals, I'm collecting the numbers 3, 68, 4, and 2. If I were to say x plus 2, it adds 2 to each of the elements in that particular vector. If I say x times 3, it multiplies each element by 3. And you can also take one vector and add another vector to it. And so I can take 3, 68, 4, and 2 and add 1 to the first element, 2 to the second element, 3 to the third element, 4 to the fourth element, and it does what you would expect. However, if you want to do algebra, you can't really do that to character strings. If I just have a string that's Andrew Jaffe, it's a length to character vector, and I try to add 4 to it, it's saying error in name, non-numeric argument to binary operator. It sounds like gibberish, but all it's really, and you would Google that and be like, oh, okay, I see what's going on. It just doesn't know how to do multiplication or addition, in this case addition, to a character string. So sometimes the error messages can be a little cryptic, but the idea is it doesn't know how to interpret this. With character vectors, what's the key with them is that the number of quotation marks encapsulated things determines the length of it. So this would be this would only have length 1. because there's only one set of quotes. You're not collecting anything or multiple sets of quotation encapsulated strings. And so now if I have this variable called y, and I just print it, it says hello world. If I make a new variable y, and I say y equals x plus 1, 2, 3, 4, which was from the previous slide, you'll see now that the value of y has been overwritten. And so you do have to be a little bit careful when you're trying to save new variables. There's really no like persistent memory to R. You'll maybe accidentally overwrite the name of an object and then have to realize that you did that. Then you'll have to basically rerun your script up to that point to undo it. There's no like undo button, so just be warned. Typically that's alleviated by using sort of better named variables. Instead of just using little x's for everything, you'll typically want a more descriptive variable name. And again, you can see what's in your environment based on the little environment tab in the RStudio session. And so again, if you add anything, it might pop up. All the one-dimensional classes will pop up under values, not under data. So that's just the way how they structure things. And then again, here it also gives you a little bit more information about what that object is that you added to your environment. And so then the class, there's some functions that give you a little bit more attributes about a given data set. For example, you can see the class of a particular vector, or a class of any R object with the class function. Here it's numeric. str is structure. That gives you just a little bit more information. So for data frames, maybe structure is a little bit more informative. For one-dimensional ones, maybe class is more informative. So this basically tells you that X is a numeric class. It's length 4, and it'll typically give you the first 6 to 10 elements and then a bunch of dots if it's like 5,000 elements long. So again, it's just a way of getting a snapshot of your data before you do things like cleaning or trying to restructure it. Another class that's also pretty useful is the logical class. This is just trues or falses. And again, with the RStudio syntax highlighting or syntax coloring, you can see that they're red, they're not black, and they're not green. And so they are a different type of data. They're not quotation encapsulated. And so this is just saying I'm collecting a true, a false, a true, and a false. This class is logical. This is useful if you want to do logical tests. So if you have data, you say, is this vector numeric? You would say is.numeric this character vector, and the answer is false. You can say is.character, this character vector, and it says true. So this is kind of classic. It's returned if you want to say subset rows, where I say, I want to take all the rows where this column is greater than 3. You'll do the logical test on that column, filter based on whether things are true, and then subset. And again, we're going to cover that tomorrow, but that's just where logical is sort of the base way of subsetting. And so it's important to note that they're not string encapsulated or quotation encapsulated. So that class is character, and it doesn't have the ability to work like you would expect. You can try to coerce each of these functions into each of these elements into a different function, but this only works for trues. I actually don't know why that's possible, but that's actually new to me right now. So just be careful when you do things like logical. Just don't use quotation marks with anything related to logical. And so just, I guess as an aside, every class has, the class itself, then it has 2 logical tests, or 1 logical test and 1 conversion approach. And so if there's an is.class, that just says, is this our object that class? Yes or no, true or false. But then there's also these whole series of coercions, things called as.class. And so if I have a character vector that's something like say I'm collecting 1 and 2. This is not a number. You're getting, y plus 2. You can't do that. You can try something as.numeric, and then it will actually coerce it to be the actual numeric class, and then you can add things to it. And so you're able to try to go from class to class. R tries to be as smart as possible when it does that. If it can't coerce it, it just returns missing and gives you an appropriate warning message. And then what's also nice about logical are that if you say sum or mean on a logical vector, it tells you the number or proportion of elements that are true, respectively. And so those are nice for just seeing how many things are false or how many things are true. And so I just had these on the next slide. So you're able to test whether certain objects are certain classes, and you can try to coerce. Typically what will happen is if you try to coerce a class that R doesn't know how to interpret, so like R knows that it's easier, the character is sort of the most basic class. You can coerce anything to be a character. If I have numbers, I can say s.character, and it returns the numbers. You can tell that they're a character string by the quotes, although it's not always super easy to tell. However, if you try to coerce something where R is like, I don't know what Andrew is and what Jaffe is in regard to a number, so I'm going to be safe and just say NA, and then give you this warning message saying NA is introduced by coercion. So the coercion part's from the as, the NAs just come because it can't make these things numeric. And so you might see that message occasionally when trying, if you think you have a whole column of numbers, it'll try to apply an as.numeric call, and you'll get some NAs thrown in there. And so if you see a message like this, you should check to see what you did. So you might not be doing what you're expecting. I guess as another aside, there's three things that'll happen when you run code. One, it works great. You don't get any messages. It gets evaluated. Something gets sort of written out into your environment. You can then do analysis on it. The second are warnings. Warnings just mean like R wasn't quite sure what you meant, so it tried its best, but you should probably definitely double check to see what it did. The third one are errors. That means R will not run, and that you'll have to check your code and debug it to see exactly what went wrong. Warnings are probably the scariest because you think you know what you were doing, but R got that wrong or something, or there's some disconnect between what you think R is doing and what R should be doing. Typically, they are coding mistakes, but they're not bad enough such that R will kill the function call. And so again, those are the ones that you have to be most careful about. Another class that's popular, again, when you do things like read.csv and don't say as.is equals true or factors. These are special character vectors where the elements have predefined groups or levels. They're called levels in R. You can think of these as qualitative or categorical variables. So if I have a character string that was just boy, girl, boy, girl, and I say factor, this looks a little bit different when you print it out. They're not string encapsulated or quote encapsulated. You sort of get text. It's not in quotes, and then I'll say this thing called levels, boy, girl. And so if you were to just run this by default, levels become alphanumeric. And so in this case, boy would be the lower level of the factor, and girl would be the higher level. And so again, if you use read.table, things default to factors. If you want to make a new one, you can take a character vector. You can give it pre-specified levels. So say you have a huge vector of character strings. You only think there should be like 4 levels in there. If you put those levels explicitly, and then what might happen is things that don't fall into those levels become missing. And so that's where, again, you have to be. That's why it's bad to have necessary character strings always be read in as factors. And so, for example, it's really easy to actually, because of that, it's really easy to accidentally swap the interpretation of your data. So say I have this vector that's case, 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 control, 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 and make it a factor. So then the first 3 elements are supposed to be cases. The next 3 are supposed to be controls. The level's case, control. Say, no, I want my reference group to be controls, right? Like you don't want cases to be the reference group. You want controls. I say, okay, levels of this factor. No, let's change it to controls and case. What actually happened was it just changed the labels on them. It didn't really actually change the underlying data. And so now you basically just swapped your outcome by accident, not knowing that. And so that's where we don't recommend factors for most things. The only time they're really useful is when you actually do modeling, where you want to specify a categorical variable in a regression model, where you explicitly say, I want the reference group to be this, so that the coefficient estimate's relative to that group. So most of the time you won't use factors until you're about to do an analysis. And then if you see factors, you should just get them out of the factor space as soon as possible. So the real way to do it would be I have this vector that's case control, again, in the character strings. I say factor case control vector, then I give levels being control, and then the case. And so now when you run that, you'll see it looks like case, 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 control, 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 levels are control, then case. You could also you can make them ordinal, which is not super common. They're sort of ordinal by default. But then you can say, if you say order equals true, it's almost the exact same thing, except for now there's these little alligator signs for your case and control labels. So this should be the proper way to designate the factors and their labels and their levels in sort of one shot. And so it's nice, and so again with the coercion, if you have a factor, you can say as.character and get the labels, and you can say as.numeric, and then it coerces the factor into the numbered ordered elements. So like, for example, if my levels are controlled in case, all the controls return to 1 and all the cases return to 2. If I were to say as.numeric, this is just nice for plotting and things like that. And so we just went over that. The date class is also super useful. So if I have character strings, So say I have January 21st, 1990, February 1st, 1989, and then March 23rd, 1988. If I say something like use the sort function on that string, it doesn't know their dates. R is not that smart. You have to actually tell it their dates. So if you try to sort these dates, it says, okay, alphanumeric 01 is obviously the smallest one, 02 is the next smallest, and 03 is the third smallest. And so there you won't get the correct sorting. There's this date class that you would instead want to convert the data into. How you do that is you say as.date, you give it the string, and you give it the pattern by which the dates are composed of. So this is just saying 2-digit month, 2-digit day, 4-digit year, and then now you get this sort of different looking object that, they're formatted a little bit differently visually. But if I were to sort it, now it knows that, March 1988 is earlier than February 89. It's pretty flexible with how you can actually import these things. You can give it days as numbers, abbreviated weekdays or full weekdays, short months, abbreviated month, unabbreviated month, and 2- and 4-digit years. And so this is useful if you do a lot of like epidemiological data collection that involve a date stamp on them or something, where you want to actually be able to plot things versus date or evaluate the effective date on some variable. And so that's a pretty popular class when you're doing public health data. There's also a package that makes it much easier called lubridate. It tries to just guess how things are formatted. All you have to tell it so you say lubridate. You just tell it the order by which of the 3 slots of a date. You have to just tell it month, day, year, or day, month, year, or year, day, month. And so there's these different functions that are just MDY. That just means, yep.
Could you back up on this one?
Yep. Oops.
So,
Sorry, too far. Yep. Yep.
where's this %M? Is it no being included in the floor?
Yeah. So you have to know the code. So like that makes it a little bit harder to use. This one's way smarter. It just says like, I know the month is the first slot, so let's just try the 4 things that months can look like. And then it also does. You also don't need to tell it that they're separated by slashes versus hyphens versus. I guess those would be probably the only 2 options, maybe periods. But so this just knows that the first slot's month, the second slot's day, and the third slot's year. This one's way, way, way easier to use. Every time I use this one, I have to open that table and like remind myself what the format of that, what I actually have to type is the string. With this, you don't have to do that anymore, and this is way more flexible. Yep.
Questions about this? Like dates where I'd like to spend hours just trying to get things proper, so
Mhm.
it's worth looking at. The first question is like Excel and many other statistical programs will classify dates as like the number of days from a given year.
Yeah.
From a specific date. I'm assuming that when we read in something like a CSV file or an Excel file, that's baked into that read underscore CSV function? Or
No, it's just a string.
Okay,
It won't. Yeah. So like, for example, in the UFO data set, like. Let me just use the other one. So, for example, at most CSVs will just give you something like this. So you can tell that it's not a date. Well, first you can just check the class of it. So you'll have to actually make it a date. It doesn't try to guess it doesn't know what a date is.
But I mean, when like sometimes it'll just be a number, like 10,000, as in
Oh,
days since
yes.
2001.
I see yours. Yeah.
So is there an easy way to convert those? And the second question is, oftentimes like the dates are recorded in a way that you have to break up the strings, and so can you take us through that a little bit?
Yeah, so we're gonna cover that more in data cleaning, like how to break up strings and things that relate to sort of string cleaning. I mean, one thing is like you would just try this first, right? Like you'd have your dates, you would see that they're sort of, they look like dates, right? And so you would say, okay, let's just try this like this lubridate function month a year. So now you'll try this. It'll try to coerce as many as it can. Then you'll get a warning message sometimes. In this case, because the data is not quite formatted correctly, but then you'll see that some didn't parse. So like one thing you would then do is you would say like which ones are missing here. Again, we're going to cover that tomorrow. But so now you'll see that the first 10 entries are in fact a date. So if I were to like, again, I'm going to cover this more in data cleaning. But so if I did like So there's a latitude, for example. This is a character. I can just make this a numeric. I'll call this L. So now if I want to plot, like, and again, this is like 80,000 rows, so it's a little bit, okay. So now, like, it knows to put date on the x-axis, right? So now if I have these dates, though, so they, visually it looks like there's just these numbers, but if you say like as.numeric, it indeed does what you're describing, or it actually has some like reference date point that's relative to some number. I think 1970 or days since 1970. I'm not exactly sure what the reference is, but you're able to recapitulate that exact number. So if you know, if you know what the reference is, you can usually convert like. And again, there's way more reference material online for just in general, just for like the date type format. For some people, it's really it's a really important class, but for other people, they've never used it for anything.
You can do math on dates like
Yeah, so so I can say like D1, like D1 minus D2. So if I subtract April 27th, 2004 from December 16th, 2005, it tells you the time difference. And you can also, there's also ways of formatting how that's structured. By default, just as difference in days. But you can definitely do math and stuff on them. Other questions? Okay. There's also a more complicated POSIX class. It's like just a more general date format. Things like system.time or the system time or sys.time come up in this format. Here it's basically date, space, time, space, maybe time zone. And again, here's where you can basically have this format. You can add periods of time to this particular date or time class. And so, for example, if you were like using the UFO data set, you'd probably want to make the first date time column an actual POSIX CT class, just so you can treat it as a date and a time. Again, you're able to plot this. You're able to sort of add or subtract, recourse back to whatever the underlying, again, I think it's like January 1st, 1970 is like the reference point. You're able to coerce things and convert things. So then other classes, so then those are each one-dimensional classes. They can be arranged in these two-dimensional classes, like a data frame. So these, again, like a traditional Excel spreadsheet. Each column can have its own class from the above one-dimensional classes. So your first column can be a character, your second could be a date, your third could be numeric. The more general two-dimensional class is something called a matrix. That's composed of also of rows and columns. Unlike data frames, the entire matrix has to be one class. So you can only have either an all-numeric matrix or an all-character matrix or an all-logical matrix. Most of the time, you'll just use data frames. Matrices are a little bit better for things like matrix multiplication. If you want to do really, really big matrix multiplication, you'll typically want to take the numeric elements out of your data frame, and it's its own matrix, do stuff to it, and maybe put results back in your data frame. It's just faster. You don't have to retain as much information. It knows it's all the same class, so R can handle that a lot easier. And so there's some useful functions when you do things with data frames. And so actually I feel like I skipped that. So there's a few things you can, if you have a vector, so say I have that date vector. One thing you might want to just check is like how many elements are in it. That's just the length function. That's also really useful. If you expect a certain number, you run length, you get that number, that's a good thing. That's pretty useful. The equivalents then in sort of two-dimensional space are n row and n column. That just tells you how many rows and how many columns are in the data set respectively. There's a sort of another function that does both at one time called dim for dimensions. That gives you a length 2 vector that's the number of rows as the first element, and then the number of columns as the second element. And then things that have, you can have named things be attributes of a particular data frame or even vector, and you can extract those with column names, which displays the column names if there are any, and then row names if there is any. And so if you're in Tibbles, they actually don't have row names. That's part of like Hadley Wickham's like clean data or sort of tidy data, is that he doesn't believe that row names should include any sort of meaningful data. Like nothing because they're really easy to remove and accidentally take off. And so anything that's actually data should be in your data frame, not as a label on your data frame. So you won't be able to actually do anything anymore with Tibbles and row names. Column names will display or change column names. And so And then the last class, which is the most generic that we're not going to really cover, except in the specific cases where certain functions return things in this format, are lists. You can use the list function to make them. They can be super, super complicated. They can be like inception of R objects. You can have lists where each element of a list is another list. We are going to stay away from that. Just as a little example, though, you can have a list, and I say I want length. It's a length 3 list. It has 3 elements. The first is a character vector called letters. That's length 3. The second to a numeric vector called numbers, which is length 3. And then the third element is just an unnamed matrix that's 1 to 25 by that's a 5 by 5 matrix. And so this is one R object that contains all these different sort of types of data, but again, you'll never really make them. Usually some functions return them. And so that just lets you sort of store a little bit more flexibly formatted data in one R object that you can then send to a collaborator. Yep.
This is kind of a weird question, but does the matrix in R always have to be a square?
No,
Say no or
it can be a rectangle. It just has to have a number of rows and a number of columns that are filled in with data. So like, for example, if you make a matrix, you have to just tell it how many rows and how many columns you want. And so you'll say, like, it can be a 1 by 7 matrix. It can be a 5 by 3. It doesn't have to be square. And sometimes when you make it, like if you give it something that's length 10, like a 1 to 10 vector, and you say number of columns is 2, it'll actually automatically compute the number of rows. You don't have to always give it all the dimensions. Yep. And so if you're in a data frame, you say column names, and so here are all the column names. So again, when you use something like readr with the read underscore CSV, it keeps the data frame names as sort of maybe not well formatted. You might notice that with tab completion actually. So if I say UFO $ date, I press tab. If you highlight one that has a space in it, it actually adds backticks, so that's above the tab sign on your keyboard. It'll add backticks to allow you to actually run that particular command. If you don't have the backticks, you can say what is posted. So it just doesn't know. So that's why you'll typically, again, you'll read in the data frame, you'll change the column name so that they don't have spaces, and then you can just play around with it. But if for some reason you just want to see what it looks like before you do that, you can then just use backticks to get around that. And again, the tab completion will do that for you. It's not a very common key to type, so sometimes it's hard to remember exactly where it is. And so then another way with data frames to extract data is with the $sign. And so UFO, so then the syntax here would be the name of the data frame, $sign, the name of the column you want to extract. And then the head function just shows the first 6 elements by default. So I'm saying head, let's look at the first 6 elements of the city column in the UFO data frame. And then again, you can see that by just visualizing, it's a character string because things are in quotes, and it seems like it's pretty much free text. And then I guess the last thing we're going to cover is, okay, you do all the stuff, you read in the data frame, you clean it up maybe, you rename some stuff and say, okay, I now want to save it as a text file on my computer, because being able to export stuff is almost pretty much as important as being able to import stuff. And so there's the write.table function. So there's no underscore equivalent to the writing outside. You pretty much have to use one of the base R functions. So that's write.table. And then the general syntax is write.table, the name of the data frame or matrix, the path to the file that you want to write it to on your computer, and then other options that you might not need. The only one you'll probably need is separating. And then also the last one is row.names. Then you say, so this, it'll ask whether you want to write out the row names as the first column of your table. And typically you don't want to do that. Typically you'll want to just have it not be anything important. Like you don't want data to, again, be stored necessarily in the row name. And this is also really annoying if you like opening things in Excel. So if you do a bunch of cleaning, export it with row names as the 1 to 50, then that's going to be the first column when you open in Excel, and that information is already sort of in Excel to begin with. So I typically say false for almost any time I run this command. So you'll give it the X is the data frame or the matrix you want to write. File is the path on your computer by which your file is written. It can be an absolute path. It could be a relative path. If you just give it file.txt, it'll write it in your working directory. So it's important to know where you set your working directory. Sep, just like when you're reading things in with either sep or delim. What character separates the columns? You'll have to give it a comma for CSV. That got ruined. A tab is a \t. This I was required to hit 2 backslashes here, but I forgot it in the notes. So it's not no space. It's actually \t is tab. That's like the standard tab delimited file format in R and in Unix. And so what you'd say is that if I want to write out a CSV file, I'd say write.csv UFO. I'm just going to extract the first 100 rows just as an example. Files UFO underscore first 100.csv. Row names is false. And so when I run this and that runs and I open it in the folder, you'll see now that only the first 100 rows have been exported, and that it's a new file on my computer. This is also where you want to be really careful to not like accidentally overwrite your original file with like the last command of write.table. That'd be pretty bad because you might not be able to recover it. And just as on that note, anything you do in R is not permanent, almost for the most part. So if you read in a file and you somehow mess up your data frame horribly, you would just start over and read in the file again. So nothing, again, R just keeps everything in R until you save it or export it. And that's the only time you have to be careful not to overwrite data or to overwrite irreplaceable objects. So you can make mistakes, you can try and play around, you can get a bunch of error messages, and then you can just say, okay, let's start over. And then, it's like it never happened. Oops. And so the last file format we'll cover, specifically for reading things in, are Excel files. Many data analysts tend to collaborate with researchers or with, Yep.
Quick question about the output. Would you ever save it as a .r file? Sorry, a .r is script, right?
Yeah, you could. There's a
Native R, like, table file?
there's .r data, there's the option called save and load, and this is in base R, and so and again the description is a little bit wonky. Save writes an external representation of R objects to a specified file. That just means you can give it basically a vector of R objects you've maybe created as intermediary files. You'd say save like data frame 1, data frame 2, data frame 3, comma, file equals intermediary data.r, RDA or .rdata. That's like a file that you can't really open like in plain text, but you can use the load function to load it back in, and that'll load all the objects into your workspace. So that's a lot more useful than writing out tables if you have to save 10 things. So you would just save 10 things with the save command. It would get saved as an rdata or .rda, and then you can then say your next script could be load. So you would load those 10 processed objects and start your analysis. That's typically what I do. I'll do like a preprocessing or data cleaning script that then basically saves an RDA or an RData object. That's basically just tables. Then my next script will load that in with all the functions required to do the actual analysis and go from there. And then I'll write out a table in plain text at the very end, like with regression coefficients that we're going to cover tomorrow and other things like that. And so this, on that same note, like sometimes when you'll close RStudio, you'll get this message saying, do you want to save this workspace image? And typically you'll say don't save. So what will happen actually in your workspace, it'll create, again, because the period means hide this file, it'll create this hidden R data file that's you will never see, and unless you like show your hidden files. And so sometimes like if you're doing a really large analysis, you'll have these like multi-gigabyte like hidden files that you just don't even know that are in that folder. And then the other issue is like when you open up a script in that folder, it'll actually load that workspace in. And so you'll be sitting there like, why is my R taking 10 minutes to load? It's because there's probably some hidden R data file lurking in that folder that you can just delete at that point. So typically when they'll say, do you want to, if you have these unsaved changes, I'll save the script, but then like not save the workspace. And so that's something that, again, it asks you, but you typically don't save the workspace.
And when you save a project, the workspace is also saved, or is it independent of the project?
The RStudio projects are like a totally separate species. That's like something only RStudio can handle. Like if you were to go to just base R, you couldn't really interact with that. And so that just by like project, I mean like an analysis that I do for work. Like if I do an analysis for work, I have like a bunch of intermediary objects that I just read in another script. And so again, our projects are nice because the way it plays well with GitHub and the way that you can sort of make other functions and code. But I don't really personally use our projects in RStudio, mostly because I work on a cluster, and so I don't really use RStudio at all. But there are benefits to our projects within RStudio, especially for like modularity. You can just give it to somebody else, and it should be more sort of self-contained. So the takeaway is you typically don't save your workspace. but you should save your scripts. So you'd uncheck this, and you say save selected, and then you'd be done with RStudio for the day. Other questions? There's just a few more slides, then we'll go to the happy hour and get a beer. And so if somebody sends you something in Excel, there's different ways you can handle that. If someone sends me one Excel file that has one sheet, I might just export it as a CSV within Excel, and then just only use read_CSV. There's also add-on packages that are, it's called read Excel, XL, and then you can also just tell it, you basically tell it the file name of the Excel, typically the XLSX or XLS file format. You tell it what sheet number to read in. By default, it reads in the first sheet number. You can also iterate over sheet numbers to read in every single sheet number's worth of data. And then you can it comes in as a tibble, just like the read_CSV or the read_delim. There's some stuff in the lab that we'll cover tomorrow that involves reading in something within Excel. But you can then just read it in and treat it like any other import. And again, because of, yep.
So do we have an audit function for read Excel package?
Yeah, so there's the read Excel library, and what happens is, like, if you were to import a data set, there's actually an option for Excel here. And so if I were to, it says, okay, this will happen the first time you try it. You say, hey, you need read Excel. You'll say yes. And then it'll install, hopefully quickly, plus all the dependencies. And so the key function here is going to be, I'll just close this first. So you'd say, library read Excel. The main function is read_Excel. And so you can do read XLS or XLSX. And again, there's a whole range of options that most of them are generally like CSV options. Other ones might be more specific to these Excel files, like sheet. You'll tell it what sheet you want to read in. There's range for which range of cells you want to read in. There's also options about how many columns or how many rows to read in. And so they're really similarly formatted. It's written by the same guy who wrote read_CSV. But again, if you want to use dropdown, you would make sure you have read Excel installed. You'd say from Excel. You'd find the Excel file and you'd import it in the exact same way. And in fact, you can see in the code preview, that's exactly what it's doing. It's saying, let's initiate library read Excel. Let's apply the read_Excel function to the actual path I would provide. And then you would just hit import.
My question is, do they have an output function in this package?
Oh, can you write to Excel? No. There's one that's called OpenXLS that can write to Excel, but it requires RJava, which can be kind of annoying to install. But you can. It's just not as easy to use. And so there's no equivalent here.
Can you save to CSV?
Yeah, you can write a table to a CSV and open that with Excel, and then save it as an XLSS. Yep.
You said if it's well formatted, you use XLSX. If it's not well formatted, you just stuck with editing Excel document and then importing it.
Yeah, it depends how unwell formatted. Like, I get data from some biologists that are like, all the data is in like standalone tables that are like across, like 20, 30 columns across. And so then I will actually like make it from like weird wide to like a long format. I try to avoid doing that just because it's not really reproducible. But then I'll just like make that the raw data. Other times it's more when like you have multiple sheets so like if you have like a 50 sheet Excel document and they're all formatted the same way, you'll definitely just want to use like read_Excel and iterate across 1 to 50, and then for the first one read it in, second one read it in, etc. So like you automate it. Sometimes that's also not possible. Like say like the first sheet skips 5 lines, the second sheet is shifted off by 1. That's where you might have to get a little bit more like creative. But for things that are well formatted across sheet, that's where like these functions are really useful. Questions? And so just the last slide was just covering, there's other packages that handle other types of data formats. So maybe you collaborate with SAS experts or SPSS or Stata experts, and they've saved stuff in .dta files or SAS7 BDAT files or all sorts of fun things. That can read, there's this Haven package also written by Hadley Wickham, I believe. That can cover reading in all these other types of data formats. And so just as an aside, if you were to find like the actual package information, the best packages have these things that are have vignettes. And that just means it tells you like how to do stuff with like code and examples using in our Markdown document. That's far preferable to the actual reference manual. which is just a default file format structure that just has all this information that just concatenates all of the help files together, basically. Those are less useful. I mean, it might show you the bare minimum of how to use something or like what stuff is, but it doesn't show you how to use it. So if there's vignettes for packages, which are typically required for things like bioconductor, which is why Jeff ranked that more highly than CRAN, you'll want to typically find things like vignettes, where there's a whole HTML file for how to read in file formats from these different dates and times from SAS, data, and SPSS. That it'll show you how to do that with with different examples with code. And so that's where having like these vignettes for a package are much more useful because you'll see exactly how to read things in and how to do things with that package. And again, most of Hadley Wickham's have these vignettes associated with them. And so this is probably the best package for reading in things from SAS, STAT, and SPSS now. The other ones are a little bit antiquated. This has been around for a long time, but it's not really that well maintained. So again, if you're going from if you're going from SAS, SPSS, or STAT, I would definitely check out Haven. If you have Excel, I'd check out Read Excel. And then for most plain text formats, the read_delim works really well. And again, tomorrow Jeff's going to go over the more complicated types of data that require different parsing that these packages don't handle, but that there's plenty of functionality in R to handle them. Any questions before happy hour? Yep.
Are you familiar with the freeze function?
Which?
Freeze from indentated package?
Oh, yeah, we're going to cover that a little bit.
I was going to ask how it compared to the read underscore.
It's more of like the type of data that reads in. It's pretty comparable, maybe a little bit faster. I don't use data table that much though, but it's just a less approachable version. Like you can't do as much like to quickly view things and to like take snapshots of data. I feel like, but we're gonna cover that. He's gonna cover that tomorrow as well. Does everybody know where the happy hour is? It's back where you picked up your registration. I think on the lower floor. I'll leave a map up here. It's in the. SCC 316, so that's the South Campus Center. Again, I believe where you picked up your IDs, third floor. That went okay.
Sorry?
That went pretty well, I think.
Yeah. It's hard to always know what people know.
Yeah.
That's it. The state question.
I installed the Read Excel library several times.
Oh, okay, so the
But
key.
it's still,
Yeah,
still if I try to do like
so the key.
read underscore Excel, it doesn't exist.
Yeah, so I'll go over this explicitly tomorrow. So all the times you only have to install a package one time, but in order to actually use the functionality in the package, you have to use that library function. So you say library, read Excel. We can try it right now. And then I type question mark, press up a few times. Yep, you can try that. Yeah, so the key to any add-on package, you typically have to say that library. Yeah, so we'll go over that tomorrow so everyone's make sure. Yeah, we went through that quickly, but yeah.
Okay, cool.
Yep.
Nice. Talking about that.
Oh, no worries.
Yep. Straightforward way to capture your